The morning air inside the Willys Overland plant in Toledo, Ohio, carries the sharp tang of welding flux and fresh paint. It's March 15th, 1943, and Charles Sorensen stands on the observation platform above the main assembly floor, stopwatch in hand, counting. 76, 77, 78. A chassis enters at one end of the line, 79, 80. A complete Jeep, painted, tested, fueled, rolls off the other end and drives itself out the loading bay door. 80 seconds, not 80 minutes, not 80 hours. 80 seconds from bare frame to combat-ready vehicle. The men who designed this line were told it was impossible. The automotive engineers who reviewed the initial plans called it fantasy. The Army procurement officers who first heard the proposal laughed in the meeting room. But here it stands, running 3 shifts, 7 days a week, producing more vehicles in a single day than some factories made in a month before the war. This is not a story about a machine. This is a story about the moment American industry stopped asking, "Can we?" and started demanding, "How fast?" If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. To understand what made this assembly line impossible, you must first understand what made the Jeep itself improbable. In the summer of 1940, the United States Army had a problem it couldn't quite articulate. The German blitzkrieg had just carved through France in 6 weeks, and military observers noted something unexpected in the Wehrmacht's success: reconnaissance. Not the heavy tanks, not the Stuka dive bombers, but the thousands of light, fast vehicles that allowed German commanders to know what their enemies were doing before those enemies knew themselves. The US Army had trucks, plenty of trucks, but they were heavy, slow, and built for roads. They had motorcycles, which were fast but carried only one man and broke down in mud. What they needed was something that didn't exist: a lightweight reconnaissance vehicle that could carry troops, mount weapons, navigate terrain that would stop a truck, and be simple enough that a farm boy drafted last week could maintain it with a wrench and a prayer. The Army's requirements document, issued on July 11, 1940, read like a wish list from a child who'd never seen a factory. Weight limit: 1,300 pounds. Payload capacity: 600 pounds. Wheelbase: no more than 75 inches, allowing it to fit into a glider for airborne operations. 4-wheel drive, high ground clearance, capable of climbing a 60% grade. Oh, and one more thing. Prototypes were due in 49 days. Not 49 weeks, 49 days. To put this in context, designing a new passenger car typically took 2 to 3 years. The Army was asking for a completely new vehicle category to be invented, designed, prototyped, and tested in 7 weeks. 135 companies received the bid request. 133 ignored it as impossible. 2 companies were desperate enough or crazy enough to try: American Bantam Car Company and Willys Overland Motors. Bantam was a small firm in Butler, Pennsylvania, barely surviving the Depression by making tiny economy cars that almost nobody bought. They had engineering talent but no manufacturing muscle. Willys Overland, once the second largest car company in America, had been bankrupt twice in the past decade and was hanging on by making light trucks and the failed Willys America. Both companies knew that if they could deliver this vehicle, it would save them. If they couldn't, they'd likely be gone within a year anyway. They had nothing to lose. The man Willys assigned to the project was Delmar Barney Roos, chief engineer, a 51-year-old automotive veteran who'd worked at Locomobile, Marmon, Studebaker before landing at Willys. Roos had a reputation for 2 things: brilliant engine design and absolute intolerance for the word impossible. When handed the Army's specifications, he didn't argue about the timeline. He cleared his calendar, assembled a team of 19 engineers, and locked them in a drafting room with orders not to emerge until they had something that might work. Bantam beat them by 2 weeks, delivering their prototype, the Blitz buggy, on September 21, 1940. It was crude, underpowered, and looked like a motorized bathtub. But it worked. The army tested it, found it promising, and promptly made a decision that would shape the next 4 years of war. They invited Willys and Ford Motor Company to examine Bantam's design and submit their own versions. Bantam had done the impossible, and now the army was giving their blueprints to their competitors. This was legal government contracts meant government ownership of designs, but it was also devastating to the small company that had taken the risk. Roos studied Bantam's prototype for 3 days, taking measurements, photographing every component, and interviewing the test drivers. Then he went back to Toledo and told his team to start over. Not improve Bantam's design, start over. The Bantam worked, but barely. Its engine was anemic, its chassis flexed under load, and its transmission whined like a dying cat. Roos wanted something that didn't just meet specifications but exceeded them. Something that could be beaten, abused, driven into hell and back, and still run. The result was the Willys Quad, delivered November 13th, 1940. It was heavier than the Army wanted, 2,450 pounds, nearly double the specification, but it was also stronger, faster, and more reliable. Its engine, the Go Devil 4-cylinder that Roos had refined over months, produced 60 horsepower and, more importantly, delivered torque across a wide range. This meant it could pull itself out of mud, sand, or snow without destroying its clutch. The Army tested both vehicles side by side through November and December. The Bantam was nimble, Willys was unstoppable. Ford, meanwhile, submitted their own prototype, the Pygmy, in November. It was well built, as anything from Ford would be, but it was essentially a copy of the Bantam design with Ford's manufacturing polish. The Army looked at all three, ran them through mud, sand, water, and rocks, and made a decision that satisfied no one but made perfect strategic sense. They would take the Willys chassis and engine, incorporate some of Bantam's design elements, standardize the whole thing, and award contracts to all three companies plus Ford to produce it. The vehicle that emerged from this bureaucratic compromise became the Willys MB, military designation, truck, 1/4 ton, 4x4. The soldiers who would drive it called it the Jeep, probably derived from the military, abbreviation GP for general purpose, though the name's origin remains disputed to this day. Whatever its name, by March 1941, the design was frozen. Now came the hard part, making hundreds of thousands of them. This is where Charles Sorensen enters the story. Sorensen was Henry Ford's enforcer, the man who'd turned Ford's sprawling Highland Park plant into the most efficient manufacturing operation on Earth. He'd perfected the moving assembly line, the technique that let Ford produce a Model T every 93 minutes back in 1913. That had been revolutionary then. Now, in 1941, it wasn't nearly fast enough. Sorensen knew that modern war consumed material at rates that would have seemed insane a generation earlier. The German army had lost more vehicles in the first 6 months of the Russian campaign than the entire Wehrmacht possessed in 1939. Production wasn't a peacetime concern anymore. It was the war itself. When Ford signed the contract to produce Jeeps, officially designated the Ford GPW, Sorensen gathered his production engineers and posed a question that would have seemed absurd to anyone outside that room. How fast could they make these? The engineers began with standard calculations. A Jeep had roughly 5,000 parts, counting every nut and bolt. Assembly required welding, drilling, painting, wiring, upholstery, tire mounting, fluid filling, and testing. Using conventional methods, they estimated one vehicle every 8 to 10 hours of line time. That meant perhaps 3 vehicles per shift, 9 per day running around the clock, maybe 3,000 per year from a single plant. Sorensen listened to their presentation, nodded, and said, "Not fast enough. I want one every 90 seconds. The engineers stared. One every 90 seconds meant 960 vehicles per day, from a single assembly line. The calculations said it was impossible. Sorensen didn't care about calculations. He cared about the German tanks rolling across Russia and the Japanese carriers that might appear off California at any moment. Impossible was no longer a word that meant anything. The breakthrough came not from inspiration but from elimination. Sorensen and his team analysed every second of the assembly process and asked, what if we removed every movement that isn't absolutely necessary? What if parts arrived exactly when and where the worker needed them, already oriented correctly, so no one wasted time searching or flipping or positioning? What if we eliminated every step that served manufacturing convenience rather than the vehicle itself? They redesigned the entire workflow from scratch. Traditional assembly meant a vehicle moved from station to station, stopping while workers performed their tasks. Sorensen wanted continuous movement, the chassis would never stop rolling, and workers would walk alongside it, performing tasks while it moved. This required perfect timing. If one worker fell behind, the entire line stopped. If one part failed to arrive at the exact second needed, the line stopped. The system had no tolerance for error, which meant every error had to be designed out in advance. The parts themselves were redesigned for speed. Bolts were replaced with snap fittings wherever possible. Complex welds became simpler joints. Paint was reformulated to dry faster. Wiring harnesses were pre-assembled offline, allowing them to be dropped into place in seconds rather than minutes. Every component was studied, questioned, and often radically simplified. The engineers discovered something profound. Ease of manufacturing and ease of field maintenance were the same thing. A Jeep designed to be assembled quickly by semi-skilled workers could also be repaired quickly by exhausted soldiers with limited tools. By June 1942, Ford's Willow Run plant near Ypsilanti, Michigan, was producing one Jeep every 120 seconds. By September, they'd cut it to 100 seconds. By December, 90 seconds. And in March 1943, Sorensen stood on that observation platform in Toledo. Willys had adopted Ford's methods and watched a vehicle roll off the line every 80 seconds. 80 seconds. The number became mythic among production engineers, a figure that represented the absolute limit of what seemed possible with 1940s technology. But numbers don't capture what this meant in practice. To sustain that pace, the plant ran 3 8-hour shifts with 15-minute breaks. That meant the line produced 22.5 Jeeps per hour, per shift, 180 vehicles per day, 1,260 per week, 65,000 per year from a single facility, and there were multiple facilities. The workers who made this possible were not automotive veterans. They couldn't be there, weren't enough of them. By 1943, most able-bodied men under 35 were in uniform. The assembly lines ran on women, teenagers, men over 45, and anyone else who couldn't be drafted. At Willys Overland in Toledo, 62% of the assembly workers were women by the spring of 1943. Many had never held a wrench before Pearl Harbor. Now they were installing transmissions, wiring electrical systems, and mounting machine guns on vehicles headed to North Africa and the Pacific. The training program reflected the brutal efficiency of everything else about the operation. New workers received 3 days of instruction, not 3 weeks. 3 days. They learned one specific task, practiced it until their hands moved automatically, and then joined the line. The woman who installed the driver's seat learned nothing about the steering system. The man who mounted the front bumper knew nothing about the rear axle. This wasn't cruelty, it was optimization. Teaching someone to assemble an entire Jeep took months. Teaching them to perform one operation perfectly took hours. On a traditional assembly line, a skilled worker could compensate for problems, improvise solutions, and catch errors. On Sorensen's line, there was no time for improvisation. If a bolt cross-threaded, the vehicle moved on. If a wire wasn't seated properly, the vehicle moved on. Quality control couldn't happen during assembly, it had to happen after. Every Jeep that rolled off the line went immediately to a testing station where inspectors started the engine, tested the lights, checked the brakes, and drove it through a short course that included mud, water, and steep grades. Vehicles that failed went to a repair bay. Vehicles that passed went to the loading dock. The failure rate in the early months was catastrophic. Nearly 40% of vehicles needed repairs before shipping. This was expected, the engineers had planned for it, but it was also unsustainable. A repair bay could only handle so many vehicles per day, and if failures exceeded capacity, the entire system backed up. The line kept producing, but finished Jeeps accumulated in the yard, waiting for repairs, consuming space and time. The solution came from statistical analysis, a field barely 20 years old in 1943. A team of quality engineers began tracking every failure, categorizing them, looking for patterns. They discovered that most problems traced to a small number of causes: misaligned parts, incorrect torque specifications, or components that varied slightly from specifications but were still within tolerances. The parts might be acceptable individually, but when assembled quickly by inexperienced workers, those tiny variations compounded into failures. The answer was tighter tolerances. Parts manufacturers were told to reduce variance by half, then half again. Suppliers who couldn't meet the new standards lost their contracts. This was harsh but necessary. The line couldn't slow down, so the parts had to improve. By the end of 1943, the failure rate had dropped to 12%. By mid-1944, it was below 8%. The Jeeps rolling off the line in Toledo and Willow Run weren't just faster to build, they were better built than the carefully crafted prototypes had been 3 years earlier. The human cost of this pace rarely appeared in official reports, but it lived in the bodies of the workers. Repetitive strain injuries were epidemic. Women who spent 8 hours a day using pneumatic wrenches developed nerve damage in their hands. Men who lifted 40-pound components hundreds of times per shift destroyed their backs. The plant medical staff treated more injuries per capita than many combat units, though these injuries didn't qualify for Purple Hearts or newspaper stories. The workers endured because they believed, correctly, that their work mattered. Every Jeep that left Toledo or Willow Run was one more vehicle that an American soldier wouldn't have to walk without. And the soldiers noticed. Lieutenant Paul Fussell, who would later become one of America's most celebrated war memoirists, wrote about his first encounter with a Jeep in England in 1944, preparing for D-Day. His unit had trained with older trucks, heavy and temperamental. When the Jeeps arrived, the men treated them like beloved dogs, giving them names, decorating them, and refusing to let anyone else drive their assigned vehicle. Fussell described the Jeep as the only army equipment that never disappointed, a remarkable statement from a man who viewed most military organizations with deep cynicism. The numbers support his sentiment. Between 1941 and 1945, American factories produced 640,000 Jeeps. The Soviet Union, through Lend-Lease, received 51,000 of them. The British Commonwealth forces used 33,000. The Free French forces, reconstituted after the fall of France, relied almost entirely on American Jeeps for reconnaissance and transport. Even the Chinese nationalist forces, fighting Japan with limited industrial capacity, received 13,000 Jeeps. But production numbers don't capture impact. Consider Normandy. On June 6, 1944, the first wave of troops landing on Omaha Beach had no vehicles. They arrived in landing craft and fought their way up the bluffs on foot. But within 6 hours, Jeeps were rolling off the landing craft, waterproofed engines coughing to life in the surf, driving directly into combat. Within 24 hours, the beaches were thick with them, ferrying wounded to aid stations, carrying ammunition to forward positions, towing anti-tank guns, serving as mobile command posts. Photographs from D-Day +2 show traffic jams of Jeeps waiting to move inland, a gridlock of victory. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Jeep changed tactical doctrine in ways no one had predicted. Before the war, military theorists assumed that reconnaissance meant cavalry, or in modern terms, light armoured cars. The Jeep was neither armoured nor particularly light, but it was fast enough and cheap enough that commanders could risk them in ways they'd never risk an armoured car. Reconnaissance in force, sending vehicles ahead to provoke enemy fire and identify positions, became standard practice because losing a jeep meant losing $6,500 and 2 men, not $30,000 and a crew of 4 in an armoured car. This calculus seems cold until you understand what it meant for the men doing the reconnaissance. Corporal Robert Humphrey, serving with the 2nd Armoured Division in France in August 1944, described a mission where his jeep took machine gun fire from a German position in a farmhouse. The bullets punched through the canvas top and the thin metal body, missing Humphrey by inches. He and his driver reversed, reported the position, and artillery destroyed the farmhouse 10 minutes later. In an armoured car, they might have tried to suppress the position themselves and taken heavier fire. In a jeep, they did exactly what reconnaissance vehicles should do: find the enemy and get out alive. The vehicle's versatility created uses no designer had imagined. In Italy, jeeps with stretchers mounted on the hood and rear became battlefield ambulances, navigating mountain roads too narrow for proper ambulances. In the Pacific, Marines removed the canvas tops, mounted twin 30 caliber machine guns, and used them as fire support vehicles in jungle fighting. In Burma, British Chindits attached ploughs to the front bumpers and used them to clear light obstacles from drop zones. The jeep became whatever its users needed it to be, limited only by its half-ton payload capacity and the imagination of desperate men. The Germans noticed. Documents captured after the war revealed that Wehrmacht intelligence considered the jeep one of America's most significant tactical advantages. Not because it was superior to German vehicles, the Kübelwagen was arguably better in some conditions, but because there were so many jeeps. A German infantry division in 1944 had perhaps 400 vehicles total, most of them trucks. An equivalent American division had 3,000 vehicles, including 600 jeeps. This meant American units could disperse, maneuver, and concentrate faster than their German opponents. The Germans understood this and had no counter to it. Their industry couldn't match American production volumes, and even if it could, they lacked the fuel to run that many vehicles. The fuel question reveals another advantage of Sorensen's assembly line revolution. The Jeep's 4-cylinder engine was deliberately simple, designed for efficiency rather than power. It consumed approximately 17 miles per gallon, remarkable for a 4-wheel drive vehicle carrying 600 pounds of cargo. Multiply that efficiency across 640,000 vehicles, and the fuel savings became strategically significant. The US. Army in Europe consumed 400,000 gallons of gasoline per day at the peak of operations in 1944. If every Jeep had been replaced with a heavier, less efficient vehicle, that figure would have been substantially higher, straining logistics that were already stretched to breaking. Logistics, the unglamorous mathematics of supply, determined the war's outcome more than any battle. The German army in Russia died not from Soviet bullets but from lack of fuel, food, and ammunition. Their supply lines, dependent on horses and railways, couldn't sustain offensive operations beyond a few hundred miles. The American army, by contrast, could project force thousands of miles from its supply bases, because it had vehicles like the Jeep handling the last-mile delivery problem. A Jeep could drive from a supply depot to a forward position, unload ammunition, and return for another load 3 times in the time it took a horse-drawn wagon to make one trip. Charles Sorensen never went to war. He stayed in Detroit and Toledo and Willow Run, watching assembly lines, counting seconds, demanding improvements. By 1944, his reputation had grown to mythic proportions among production engineers. When the B-24 Liberator bomber program fell behind schedule, Sorensen was called in to fix it. He applied the same principles: continuous flow, pre-positioned parts, elimination of wasted movement. Willow Run, which had struggled to produce 1 bomber per day in 1942, was producing 1 per hour by March 1944. The military promoted the story for propaganda purposes, but it wasn't propaganda. It was documentation. The workers knew what they'd accomplished, even if they couldn't quite believe it themselves. In April 1945, as the war in Europe entered its final weeks, the Willys Overland plant in Toledo produced its 250,000th Jeep. The company held a small ceremony. Management presented the vehicle to the Army representative, workers posed for photographs, and then the Jeep drove away to be loaded on a ship. There were no speeches about victory or freedom. Everyone was too exhausted, and besides, the line was still running. The next Jeep was already taking shape. Barney Roos, the engineer who designed the Go Devil engine and refined the Willys MB into its final form, received little public recognition during the war. He was too busy engineering the Jeep's successor, the CJ2A, intended for civilian use after the war, to worry about fame. But in a letter to his wife in May 1945, preserved in the Willys Overland archives, he wrote something that captures the strange pride of men who build rather than destroy. I have seen the photographs from Germany. Our Jeeps are in every picture, often with German soldiers riding in them as prisoners. I built something that outlasted the 1,000-year Reich. That will do. The final production numbers, compiled after Japan's surrender in August 1945, told a story that Hollywood could never quite capture. 639,245 Jeeps produced between 1941 and 1945. Average cost per vehicle, $6,500. Total program cost, approximately $4,150 million. For comparison, the Manhattan Project cost $2 billion. The United States spent twice as much money on Jeeps as on atomic bombs, and the Jeeps probably contributed more to victory. You can't occupy territory with a mushroom cloud, but you can with a quarter-ton truck that refuses to quit. The Jeep's influence extended far beyond 1945. When the war ended, the question arose, what to do with all these vehicles? The military kept some, sold others as surplus, and mothballed thousands more in storage depots. But the design didn't die. Willys began producing civilian versions in 1945, the CJ2A, then the CJ3A, then a succession of models that evolved into the modern SUV. The Land Rover, introduced in 1948, was explicitly designed to be Britain's answer to the Jeep. The Toyota Land Cruiser, first produced in 1951, started as a direct copy of the Jeep for Japan's National Police Reserve. Every modern four-wheel drive vehicle, from Range Rovers to pickup trucks to crossover SUVs, traces its lineage back to that 82nd assembly line in Toledo. The specific innovations, standardized parts, continuous flow assembly, pre-positioned components, statistical quality control became fundamental principles of modern manufacturing. Lean production, just in time. Delivery. Six Sigma quality control. These are all descendants of the methods Charles Sorensen and his engineers developed to make the impossible merely improbable, and then make the improbable routine. But the deeper legacy isn't mechanical, it's philosophical. The Jeep proved that American industry could outthink problems, it couldn't outmuscle. The Germans had better tanks, better machine guns, better artillery. The Japanese had longer-range aircraft and more experienced pilots at the war's start. America's advantage wasn't quality, not initially. It was quantity, married to adaptability. The assembly line that produced a Jeep every 80 seconds wasn't just fast, it was flexible. When the Army requested modifications, a different mount for the machine gun, reinforced suspension for airborne operations, waterproofing for amphibious landings, the line adapted within days, not months. This adaptability reflected something distinct about American industrial culture in the 1940s. The engineers weren't trying to build the perfect vehicle. They were trying to build a good enough vehicle quickly enough to matter. Perfect was the enemy of sufficient, and sufficient was all that was needed to win. The Jeep had flaws. It rolled over easily, its short wheelbase made it unstable at speed, and its canvas top provided no protection from weather or bullets. But none of those flaws were fatal to its purpose, which was to be there wherever there happened to be when American forces needed mobility. The men who built the Jeeps returned to civilian life with skills they'd never needed before the war. Women who'd operated drill presses and pneumatic wrenches found factory work after the war, though often at lower wages than they'd earned during the conflict. The plant in Toledo retooled for civilian production, then military production again for Korea, then civilian production again, then military production for Vietnam. The line kept running, in various forms, for decades. As of this writing in 2025, descendants of that 1943 assembly process are still producing vehicles at the Toledo complex, though the 80-second cycle time is long gone. Modern Jeeps take hours to build, not seconds, because they're infinitely more complex. But the philosophy remains: build what's needed, build it well enough, and build enough of it to matter. The last combat veteran of World War II who served as a Jeep driver died in 2023 at the age of 103. His name was James Redfern, and he'd driven a Jeep from Normandy to the Elbe River, through France, Belgium, and Germany, carrying officers, supplies, wounded men, and once, memorably, a pregnant French woman to a field hospital where she delivered a healthy son. In his final interview, recorded 6 months before his death, Redfern was asked what he remembered most about the war. He talked about friends lost, battles survived, the boredom of occupation duty. Then he paused and said, "That Jeep never quit on me, not once. I tried to kill it 12 times, drove it through rivers, through minefields, ran it on empty until the engine should have seized. It kept going. I guess that's what we all did. We kept going because that's what you do." Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.